Okay, welcome back everyone. We're going to look at three key ideas in this video. How to find the modulus of a complex number, how to find the conjugate of a complex number, and how to divide complex numbers. The first bit we're going to look at here is how to calculate the modulus. Now the modulus simply just refers to the length or the magnitude of my complex number. Now we have looked at this before in Unit 1 and 2. To find the magnitude or the modulus of z, that is simply going to be equal to the square root of my real component of z squared plus my imaginary component of z squared. If z is equal to this little green dot here, that means z is equal to 4 plus 2i, then the magnitude of z would equal the square root of 4 squared plus 2 squared, which in this case equals the square root of 20. If I simplify my surd, that's going to equal 2 root 5. So again, to find the modulus, I square my real part and I add that to the square of my imaginary component of my complex number. Now let's look at how we can find the conjugate of a complex number and just refresh what this idea is and how it works, why it's so important. If I have some complex number z, and I say that's equal to, let's just do 2 plus 3i. Well, the conjugate of z, which is simply just written as z with a flat bar on top, will be equal to the real components. That part's going to stay exactly the same, except instead of being plus 3i, it's going to become minus 3i. So the only bit that changes with my conjugates is this little symbol in the middle. So to find the conjugate of any complex number, my complex number stays exactly the same. I just swap the sign in the middle. If it was 2 plus 3i, it becomes 2 minus 3i. Let's say it was 1 minus I, it would become 1 plus I. So if it's a negative, it becomes positive. If it's a positive, it becomes negative. Now, the reason why this works, if I have a look at what happens if I multiply these two numbers, is if I have z multiplied by the conjugate of z, well, that's going to equal 2 plus 3i multiplied by 2 minus 3i. That is simply just going to equal 2 times 2 is 4, 2 times negative 3i is minus 6i, positive 3i times 2 is positive 6i, and 3i times negative 3i is going to become minus 9i squared. What happens here is my terms in the middle, negative 6i plus 6i, is going to equal 0. I also know that I squared is simply just minus 1. So what I'm left with is 4 minus 9 times negative 1. Order of operations, I do 9 times negative 1, and what I'm left with is 4 plus 9, which simply just equals 13. So if I multiply a complex number by its conjugate, I'm left with a real number. So this gives us a way to eliminate our imaginary components from our questions. If I look at this example here, find the conjugate of the following. Well, in part A, I have 3 plus I. To find my conjugate, my real part's going to stay exactly the same, so that's still going to remain as 3. And now I swap the sign of my imaginary component. It's positive I, so that's going to become negative I. If I look at part B, it's just a real number, so it's a little bit of a trick. Again, I don't change anything in terms of my real numbers, so the answer is still going to be 7. For part C, negative 2 minus I, again, my real part stays the same as minus 2. Swap the sign, that's going to become plus I. Now, I've labeled this as division. In reality, it's just kind of rationalizing my denominator for fractions where I have complex numbers on the bottom. Just like with surds, we want to try to get all of our surds, all of our complex numbers to be all on our numerator with a nice rational denominator on the bottom of my complex number. So, if I want to write part A as just A plus BI, or as just a real part plus an imaginary component all on top as a nice neat numerator, I want to find a way to eliminate the complex numbers from my denominator. Now, we just learned how to do that. That is by using our conjugate. Again, very similar to how we rationalize complex surds on our denominators in previous years of learning. So in order to simplify this, I'm going to have my original fraction 2 minus 3i, and I now want to multiply it by the conjugate of my denominator. No matter how complex these questions get, it's always the same idea. I multiply by the conjugate of my denominator. In this case, it's 2 minus 3i, so the conjugate is going to be 2 plus 3i. Now I'm going to multiply top and bottom in order to balance my equation. If I go ahead and do that, that is going to equal, well, 1 times 2 plus 3i is going to equal 2 plus 3i. And on the bottom of my fraction, I'm going to now have 2 minus 3i multiplied by 2 plus 3i. So this gives 2 plus 3i over, if I expand the bottom, 2 times 2 is going to give 4. Again, my middle part is going to cancel out, and negative 3i times positive 3i is going to give negative 9i squared. Again, I squared is going to be a negative number, and negative 3i times 3i is going to give negative 9i squared. Again, I squared here is just minus 1, so this becomes 4 plus 9, so we can just neaten that up. That becomes 4 plus 9, which is simply just equal to 13. So my final answer here is going to be equal to 2 plus 3i all over 13. Again, the question wanted me to express this as a plus bi. So my final answer can look like 1 over 13 outside of 2 plus 3i. That is a neat, fully simplified solution to part A.